In this video, we're going to learn how to what's called complete the square. This is yet another method to solve those quadratic equations. If we cannot factor, then we need to be able to still solve. We have learned how to use the quadratic formula. Now we're going to learn how to complete the square. Why do we need another method? Well, just to tell you, completing the square is used for other applications in your next math classes. Let's just review something. Do you remember these types of trinomials? Those were called perfect square trinomials. And how did we factor them? Well, what happens when you factor perfect square trinomials is that you get the same binomial times itself that we can write like that, a binomial squared. So this process of completing the square, believe it or not, we're going to create perfect square trinomials. We're going to create these perfect square trinomials in order to be able to factor them like this. So let's say I had something like x squared minus 10x. What would I have to add to make it a perfect square trinomial? Well, if you remember, when you factor this, 3 times 3 is 9, 3 plus 3 is 6. Well, what could I add the same thing to get a negative 10? Negative 5 and negative 5, which would be 25. That's how we're going to approach completing the square. So let's look at our problems. In order to complete the square, we have to have a quadratic equation in standard form, meaning set equal to 0. And what we're going to do, since we want to complete the square, we need to get this to the other side. So we're going to move it to the other side, and I like to put blanks. So let's do that. But let me read step 3. If a is not equal to 1, we have to make it 1 by dividing all those terms. So let's just take it a step at a time. A is 1. I'm going to move this to the other side, and when I move it, I'm just going to leave a blank where it once was. When I move it to the other side, I'm adding 11 to both sides. So that's positive 11. And then I'm going to put another blank. Now, why am I doing that? I want to remind myself whatever I do on the left side, I want to do on the right side. Now it says take half the coefficient of x. Well, that's positive 8. What is half of positive 8? Positive 4. And it says square this and add it to both sides. And yes, you could write 16, but let me show you why I'm not going to do that. Because now I have created a perfect square trinomial. Let me just come over here and show you what we've done. We now have 8x plus 16, and how could we factor that? Would be those same binomials squared. So instead of going through this long process, although that's really what we've done, we're going to go straight to factoring it, and we're going to rewrite the left-hand side as a squared binomial. This letter goes here, and then half of that coefficient goes there, including the sign. So half of positive 8 is positive 4. And notice, if you were to FOIL that out, you would get 8x squared plus 8x plus 16. Now on the other side, we just have 11 plus 16, which I believe that's 27. Now we want to solve by the extraction of roots method. That was the previous method that we saw. So how do we do that? Well, we want to get rid of that square, so we want to take the square root of both sides, and remember our plus or minus sign. We want to simplify that square root, so that's 3 times 9. The square root of 9 is 3. Then I still want to solve for x, so I'm going to subtract 4 from both sides. It's not hard, it is just a little bit different. Okay, so we have to just go through those steps and remember our extraction of roots method. Let's look at the second example. So again, we have it written in standard form. A is 1, that's very important. So I'm now going to move this constant to the other side, leave a blank, and I'm always going to say plus because I want to add to both sides. So when I move a positive 18 to the other side, it becomes a negative 18. Now I want to take half the coefficient of x. So that's half of negative 6. That's negative 3, and I want to square that and add it to both sides. Once again, I have created a perfect square trinomial that factors with x, and remember, whatever half of this is, whatever half of negative 6 is, which is right here, which is negative 3, equals negative 18 plus 9, which is negative 9. Now I can go ahead and solve that by what's called the extraction of roots method. So I want to take the square root of both sides. Don't forget that plus or minus sign. Ooh, what's the square root of negative 9? That's 3i. Remember, that's an imaginary number. And then we need to add 3 to both sides, and I get x equals plus or minus 3i plus 3. And just to remind you, that is two answers because of that plus or minus. Yes, those two examples were very easy. Let's see what makes it not easy. Well, that looks just as easy. Well, my coefficient is 1. I can move the 13 to the other side, and since it was negative, it comes across as positive. Now, I want to take half of the coefficient of x, which is 3. So 3 times 1/2 is 3 over 2. That's what makes this a little bit harder, because this number is odd. When you take half of an odd number, just put it over 2, and you want to square it and add it to both sides. That's the bad news, lots of fractions. Okay, but when you factor this, don't panic. You're going to put x and then whatever half of that 3, which was 3/2, equals 13 plus, now we have to square this. 3 squared is 9, 2 squared is 4. Now we have to do some arithmetic, find a common denominator. So I need to multiply both of these by 4. So I have 52/4 plus 9/4, which I believe is 61/4. Now I'm ready to get rid of that square, so I take the square root of both sides. Plus or minus, 61 is prime. It does not factor, so I'm going to leave it as the square root of 61. But the square root of 4 is 2. And then the last step is to subtract 3/2 from both sides. So I get x equals plus or minus the square root of 61 over 2 minus 3 over 2. Another way I could have written that answer is plus or minus the square root of 61 minus 3 all divided by 2. Or I could have turned that around, kept the negative 3, and written it like that. And that looks like it would have come from that quadratic formula. So we have some fractions. Now it gets harder, because a is not 1. So what do we have to do? We have to make a equal to 1. So just divide everything by a and reduce. So I have x squared minus x plus 5 still equals to 0. Now I need to move my constant to the other side, and this time it becomes negative because I would subtract 5. But what's the coefficient of x? There's a 1. Again, that's an odd number. So when you have an odd number, to take half of an odd number, just put it over 2. It's negative 1 times 1/2. Right? And we want to square it. Not that hard. Take a deep breath. Now we're ready to factor it. Remember, it's x and then whatever half of that is, and that's why I write it as negative 1/2. I don't go ahead and square it because that helps me put it in that parenthesis. So I have negative 5 plus, now when I square a negative, it is positive. 1 times 1 is 1, 2 times 2 is 4. So again, I have to do some arithmetic. Multiply both of those by 4, so I have negative 24 plus 1/4, which I guess is negative 19/4. Then we're going to take the square root plus or minus. 19 is prime, the negative means it's imaginary, and the square root of 4 is 2. And then the last step is to add 1/2 to both sides. So that's a perfectly good way to write the answer, or I could write it as one big fraction like that. How could you check your work? You could work this problem by using the quadratic formula, and you should get the same answer. One last example with lots of fractions. First of all, you should notice that a is not 1. So we need to divide everything by 3. And this time, it's not as nice. So I have x squared plus 5/3 x plus 7/3, oops, equals still to 0. Then I'm going to move my constant to the other side, and it becomes negative 7/3. And you're going, oh, okay, here's the coefficient. I have to take half of 5/3. You just multiply by 1/2. I cannot reduce that, all right? 5 times 1, 3 times 2. It's not that big of a deal. So I have 5/6 squared to both sides. And again, factoring it is easy. We have the x and then half of this number, which is positive 5/6. We're going to square that fraction. And then we need to add those two fractions. So I'm going to come over here, negative 7/3 plus 25 over 36. I think I need to multiply this times 12. So that's negative 84 over 36 plus 25 over 36. I'm going to get another negative answer. Not all of yours will be negative, which means imaginary. So let's see, what is that? We have a 9, 59, is that right? Over 36. Then we take the square root of both sides, plus or minus, imaginary because of the negative, 59 is prime, means it can't be factored, and the square root of 36 is 6. And then the last step, move this to the other side by subtracting it. So this one has lots of fractions. You just need to be very careful and go through the steps of the process.